Hello everyone, thank you for watching my video, and I am with a new video today. That will be the part number 2. In my previous video was on DOSY, COSY, HSQC, HMBC, 2D NMR. So today I'm going to show the second part, where mostly it will be like application and how to process those NMRs and how to utilize those NMRs to understand a project or a structure. So let's see how I can imply those NMRs for a project. So here you can see the structure of an acid. If you see, this is a carboxylic acid, and in presence of EDC, it goes a coupling with the carboxylic acid form the anhydride. So if you understand correctly, so that can be done like intramolecular anhydride formations to make this macrocycle. So like this is structure C2AN. Along with this, definitely these hydroxyl group also can make another anhydride with another molecule of this carboxylic acid, that is called, you can say, intermolecular anhydride. So that can be connected, many of them. So you can see the formation of dimer, trimer, tetramer and oligomer. But definitely some that macrocycle is forming. So how can we prove it? So there is a project I have worked on, and that to understand that formation of the macrocycle, so I took help of this DOSY NMR and HMBC, HSQC, the 2D NMR. So let's see a little bit more background about it. So here the NMR of that molecule is like, if you see this molecule, like there are two kinds of proton we were targeting, like one is H alpha and H beta. In this structure, if you see, these hydrogens are H beta, and specifically we were like really interested for this peak H alpha, which actually was indicating that it is forming the macrocycle, and that is small macrocycle versus the other molecules. So if you see, the NMR is like very crowdy, but we always followed this specific peak, and even in presence of different alkali metal salt. So we monitored here, it is in front of the alkali metal salt, but we also monitor the formation of this anhydride, and we also monitored this peak specifically. It increased and later on it decreased slowly. So we made sure that this is the specifically CH2 peak, which is H alpha. So we have to prove that like this is the H alpha. So we designed some experiment. First of all, we did the DOSY NMR. So if you don't know what is DOSY NMR, or like how to do the DOSY NMR, then I can give you a direction. So let's see what is the DOSY NMR. So this is the DOSY NMR actually looks like. So in DOSY NMR, you can think of like there are like same line, some you will see some peak with the same line, that will be the same compound. So if you have like many compound present, like oligomers, like dimer, trimer, tetramer, pentamer, something like this, or like you make some polymeric oligomers, or like you have biomolecules. So to identify how many entity are there, so to do that, like people do the DOSY NMR. It is based on the molecular weight and the density. So and here in the DOSY NMR, always like a smaller molecule will show on the first layer, like or top layer, or the smaller molecule show up first, and then slowly as you go down, the increasing the molecular weight, and definitely the density is dependent on the molecular weight. So then it comes later. So the heavier molecule will come later. So this is the way like people do the DOSY. So how I did this DOSY and how to do the process, please go to my channel and watch my previous video on DOSY NMR. So there is a big video on how to take the DOSY NMR in 500 megahertz NMR, Bruker NMR, and also how to do the process, so you will understand clearly. And here why we did the DOSY NMR. So definitely we suspected that small CH2 peak, this is the CH2 peak, and that is corresponding that macrocycles. And in terms of this mixture, from this mixture we are clearly seeing this is the like kind of top layer. So that is our initial suspect. Yes, it is the macrocycle forming in our reactions. So if you see more closely, like more zoom conditions, so you see that this peak corresponding this, and this is almost kind of top. And you might ask, like, what is this? Those kind, there are sometimes some always artifacts, like because the EDC reaction and EDC always converting to EDU urea, so those kind of things are like more smaller than our target, that macrocycle. So that can be like early, but this is our macrocycle and these corresponding peaks. Now we have to prove that this peak actually that H alpha in that structure. So we can determine that peak with the help of like HSQC and HMBC after doing the DOSY. So let's see how to do those HMBC HSQC thing. So here we can show, this is the like Mastronova software for the NMR processing. So here I have the NMRs. Remember that to you need to take the HMBC HSQC based on the like process on your NMR machine. And suppose I have those, but to process those NMRs you have to have the proton NMR, like 1D proton NMR also of that compound. So first open that 1D proton NMR, and then also you have to have 1D carbon NMR. So you open those carbon NMR, and also then you can open HSQC. So normally HSQC, as I mentioned in my previous video, like HSQC normally determine the carbon with directly attached with any specific hydrogen. So if you remember that, so let do that. So this is the HSQC. I'll show how to process those. Just let first open this. Now I'm opening HMBC. So HMBC is later. So first of all, when you open your proton NMR, click right mouse and then go to the phase correction, make it automatic. Okay, now decide any peak you know. So I know this peak is from acetone and it should be 2.05. So what I can do, I will do the reference and go to click reference and click on that peak, and it will show you like 2 point something. So just correct it 2.05, and once it is done, then it's done. Then go to the carbon NMR again. Carbon NMR, here the carbon NMR looks good, like no auto phase, but sometimes if it is like phase is very bad, then you can correct the phase, and then click right mouse and do the reference. And here just what you can do, the middle peak normally is 29.3. So click it and it will be adjusted like that. So this is that carbon NMR of that mixture. Now go to the HSQC. You might see some bluish and yellowish thing, so that is not corrected. So click right mouse on it and go to phase correction and do the automatic, so it will be corrected, it will correct the phase automatically. So this is the HSQC. So and now you can increase this carbon NMR, and if you want to increase this proton, so just click on this proton pen and just make it scroll it up and down. Now we are interested only this peak. If you see this peak, so now click Z, so you can get this zoom button and just select this box and then zoom it. Okay, and now again make sure that you're not losing any peak, especially this area. Zoom it. So if you see here, then you'll see definitely we adjusted the 1D proton and 1D carbon with a certain value. So also in the 2D, make it full screen first. So we know this acetone, so zoom that part, and in terms the acetone, just adjust that peak, like reference it. So this is middle, that is, you can see that the proton is not matching here, and also carbon will not matching. So just click middle of this, right mouse click and go to reference, and here for the 2D NMR, so you will click it and you will see F2. So F2 means the proton value. So carbon proton value for acetone, this peak especially is 2.05. So we will give okay, but F1 will be the carbon NMR. So you can just choose the carbon as like 29.3. So you change the F1 as a carbon and F2 as a proton, and then click OK. And now these will be adjusted accordingly. So now all peak will be adjusted. So here we can do click Z again, Z for zebra. So here you'll get zoom area, then just make it more, a little bit more zoom, and now you can see that peak is matching. So that's how you have to adjust your peak with the solvent, then automatically your compound peak will be adjusted. So this is, you can clearly see the 4.5, that peak with actually that is like this, like 68. Remember this, the carbon is 68.79, so that carbon is matching this 68.79. okay, so specifically this CH2 peak with this carbon, see this 68.9, remember that carbon especially. So now we know that the HSQC is normally that proton peak with the corresponding carbon peak. And you can also see the solvent peak. You know that the acetones, right? So acetone has a CH3 like hydrogen. That hydrogen is coming with this carbon, so that's why you can see this peak. And acetone has also like C double bond O, but it doesn't have any proton C double bond, and in this case you will not see any peak here because no hydrogen is there. So normally the HSQC, you can see the direct carbon which is directly attached with a specific proton. So that's what I am saying, because acetone has a CH3, so you will see the proton matching with this, and also it will matching with this. So if you if we make little zoom again, full screen, so this area, so you will understand that part then. So clearly this is CH3 peak, like the proton, and that carbon is here, and that carbon is getting splitting, you know, there is some deuterated thing and splitting pattern, so that's why you are seeing this splitting. Anyway, so I'm trying to say with the HSQC you can directly find out the proton connected with the carbon. So now I can make the full screen again, and our target peak was this, like the peak at 4.5. so that is this carbon. Okay, so once we know this is the carbon with proton with this carbon, like 68.9. maybe we can zoom a little bit more, and sometimes some weird reason exactly center you may not see that peak. So that's the limitation of the Mastronova. So just remember that 68.81, that carbon is that proton, like CH2. And you know, like with the DEPT 135 and DEPT 90 carbon NMR, you can get the pattern of the carbon, like which is CH carbon or CH2 carbon or CH3 carbon. So we also checked this carbon is CH2 carbon. So first of all, with this HSQC, we get this peak connected with this carbon, and then that value was showing CH2 carbon in the DEPT experiment. So we are kind of confirmed this is CH2 carbon. Now if you go back to the structure, then okay, now let's work or like process the HMBC, then the story will come. Like, so combination of this HSQC and HMBC, you will understand what we are exactly trying to do or what we have done. So here also, first of all, just right mouse click full screen, and again right mouse click first phase correction, and looks like phase correction is automatically done. There was no issue with the phase correction. And now here in the HMBC will show the relation of any carbon with the next another carbon where it has a proton. So if you see here, like click here and increase the carbon, okay, let's do the full screen first. So here you'll see like the acetone carbon, like carbonyl carbon, acetone, and here this acetone proton, and you will see a corresponding peak with that acetone. So first of all, just right mouse click, go to reference and click reference, and again click on it, and then first of all it will be 2.05. okay, and F1 value it will be 206 point something. Okay, assume that 206. okay, the carbonyl peak of the acetone. Now you can clearly see that acetone peak has the acetone CH3, that carbon and the carbonyl is totally different, but they have a cross peak. That means the carbon with the protonated carbon CH3, that peak, like that proton peak, is showing a relation with the carbonyl peak. That is like the next carbon. So with this HMBC, now if you go to the full spectrum, and we have that peak again. Okay, so we can make it zoom again. Just don't lose this area. Now see that. Okay, so these again, definitely this proton, you know what, since we know that this carbon was actually reference, so okay, we can show you the things. You can see that again, just zoom it again. So we are targeting only this peak. Now see, this protonated has a cross peak. Okay, that cross peak also matching with another cross peak that is like around 168, okay, or 167 something. So that is for the anhydride peak. Okay, so if you remember our original reaction, that anhydride, so that anhydride carbon is 167 and that is CH2, right? So that carbon is corresponding with this carbon in HMBC. So with the HMBC we can easily find out that okay, this carbon has a relation with this carbon, and that is actually matching in the HMBC. So that's what I'm trying to show here. So that was originally that CH2 carbon, and it has a peak here, that proton peak, that cross peak, and that cross peak is also matching with this anhydride carbonyl carbon because it is next to that CH2. So hopefully by this way we almost confirmed this macrocycle, and I think with this video you understand how people use HMBC and HSQC together. So if you have more question you can ask me, and especially this project is described in a paper published in 2000 this. So you can find this paper in Chem System Chem 2022. So I was the first author of this paper. So if you have more interest to know, so this paper was like carbonamide induced formation of transient polyether cages, and this is my name. And you will see the DOI number. It is open access, so you can download it from anywhere in the Google it, and then you will get it. So this is the DOI number, and definitely you will see the more page number is Chem System Chem 2022 4, and this E2022000016. So this is the paper. We described almost everything here, and also you can look in the supporting material to see how every NMRs are corresponded in like utilized to identify and determine those macrocycles and effect of the alkali metal salt on those ground ether macrocycle or case molecules. So if you have any questions you can definitely ask me in the comment section. Now I'm going to show in my channel page. So if you go to the go to my channel page, MH space Chem, C is capital CHEM Chem, and if you go down, so you will see this video, DOSY NMR, how to run in 500 megahertz Bruker NMR. And in this video I totally showed how to take the DOSY NMR and how to process those NMRs. And definitely the NMR processing system, you can use either the Masternova NMR software. If you have that, you can use this. And there is another video that is called Spinworks. There is also the free software for the NMR processing, so you can use the download the Spinwork, and then you can watch this video how to process your NMR. And also there are like some more NMR videos. So here I showed shortly like HMBC 2D NMR processing with Mastronova, so you can watch that video also, like how to do the HMBC processing. And definitely you can watch some more video. And in my discussion I didn't talk about the COSY. So if you look on these two video, COSY 2D NMR processing with spin work part 1 and 2D NMR analysis HSQC NMR interpretation part 2, so you will get clearly good idea on COSY NMR, like how to process. So if you have any questions on COSY, you can definitely ask me in the comment section. And please subscribe my channel and refer to your friends or colleagues like who are learning or doing organic chemistry research or learning organic chemistry and interested. And please subscribe my channel, and then I will get more inspiration to make more video. So till today, like that's it for now. So